Okay, so we need to start with talking about possible rational roots. So if we have a polynomial and it's a higher degree than 2 and it doesn't factor nicely, we need a way to figure out what the zeros might be. So this possible rational roots allows us a way to find things to check with our division. So do you guys remember doing your P over Q list from last year? Yes, that's what we're going to start with. So let's do the possible rational zeros. Then find all zeros. So our function here, f of x equals x to the fourth minus x cubed minus 5x squared plus 3x plus 6. So we are going to do a P over Q list. Your constant is where the values for P come from, and your leading coefficient gives you the values for Q. So what you're looking for are factors that give you a 6. What's the only ways we can get 6? 6 times 1 and... Okay. What about negative 6 times negative 1? Yeah, negative 3 times negative 2. Okay, so we're going to do a plus or minus just out in front of our whole list. Okay. And then your leading coefficient, this example is super easy. What is your leading coefficient? Well, the term is x to the fourth. What's the coefficient? 1. Yeah, so the only way to get 1 is plus or minus 1.
So this is Q to be the coefficient.
It's the coefficient on your leading term, and P is just the constant. Okay. All right, now all you have to do from here is make the fractions. Very easy this time since our only denominator is a 1. So our possible rational zeros would be plus or minus 1 over 1, 2 over 1, 3 over 1, 6 over 1. Okay? Simple. Again, I know this is a simple one to start with. But does that make sense where we come up with those numbers? Okay. Now, is that going to find every zero of this polynomial? No, it only gives you the possible rational zeros, okay? So irrational numbers like radicals that don't simplify, imaginary solutions, those are not going to show up in this list. This is just rational numbers that are your possible zeros here, okay? All right. So then the direction said find all the zeros. So what I need to do from here is test these values until I find something that works. So you have 8 numbers to test, okay? How do you test it? Plug it in or do synthetic division. I'm faster with synthetic division than I am doing like negative 3 to the fourth minus negative 3 cubed, okay? So what number do you want to take? 1? Okay, we'll start with 1. 1, negative 1, negative 5, 3, 6, 1, 1, 0, 0, 95, negative 2. Is that going to work? Am I going to get 0 as my remainder? Did I go too fast? I do synthetic division. Okay. You guys are good with adding and multiplying. So throw out the 1. That's not going to work. What else should we try? Negative 1. I like that. Okay, that worked. What degree polynomial do I have with this if I were to write out the polynomial? X to the third, right? So when you get to this stage, you can look at it and go, okay, it factors by grouping or it doesn't factor by grouping. If it doesn't factor by grouping, what do you think we should do? Do it again. Yeah, start with these as your coefficients and pick another number from your list. Okay? This one does actually factor by grouping, but let's just go through the synthetic division one more time so I can show you what I mean. Let's pick 2 this time, okay? So I'm just going to start right where I left off and do 2. So I would have 1, 2, 0, 0, 3, -6, 0. Does that make sense? Synthetically dividing, just now we're down to an x squared because we divided again. Okay. So I now have x squared minus 3. Can I set that equal to 0 and solve? Yeah, x squared equals 3. So x is plus or minus root 3. It was a 4th degree polynomial. So how many zeros would you expect to have? 4. Do I have 4? Yeah, what are the other 2? -1 and 2. Okay, good. Make sense? Okay. Again, if you get to this point and it factors nicely and you want to just factor, that is completely fine. I just want to make sure you're aware of another option if it doesn't factor when it's 3rd degree. Okay. What if you get to this point and it's quadratic and it doesn't factor or isn't easy to solve like that? What other methods do you have? Complete the square or quadratic formula? Yes, I'd go with complete the square if I were you. But. All right. So far, so good? Okay. Jumping around a little since we only have 35 minutes. Okay, so you guys are going to try this time. Find all zeros. So your f of x is x to the 4th plus 2x cubed minus 7x squared minus 20x minus 12. So I'd expect 4 zeros at the end. Let's go ahead and give it a shot here. actually don't start. What I'll do, guys, what I'll do on a test where time can be a little tight. I don't want you to sit on a problem like this for 30 minutes because you couldn't find one, you know, because you made one sign mistake somewhere on the one that worked. I'll give you, like, I'll tell you make the list of P over Qs, and then I'll say, like, -2 is one of the solutions. Go from there. Okay? So you'll have somewhere to start from, so you won't just spin your wheels forever on synthetic division. Has anyone found one? -2, okay. -1. Okay. So if you were stuck, try -2, -1. That'd be faster. There are 4 of them, guys. And they're all so that say, but that's still 4 zeros. It's not 4 distinct zeros, but it is 4 zeros. Yeah. So we said -2 words. And then -2 worked again, right? All right, so did you get -2 as a double root, 3 and -1? Okay, and it doesn't matter which one you find first, like the order you find them in has nothing to do with what the zeros actually are. They're all the same zeros no matter what, okay? Let's do one more just making the list of P over Qs. Just to make sure you guys are okay with that if it's a little more complicated. So just find the possible rational zeros. So if all I ask you for is possible, please do not do very much work, okay? That just means make the list and stop. Okay? Don't try to find what works. So let's say we have -6x cubed plus 2x squared minus 9x plus 5. Okay, so I just want you to find the P over Q list. I'll give you a second here to try. That's fine. Yeah, you don't have to write it in front of every single term. That gets very tiresome. All right, guys, so your numerator, your possible numerators were just 1 and 5, right? Denominators, we had 1, 2, 3, 6. Okay. Just have some sort of organized method for actually making your fractions. I'm going to do both numerators over the first denominator and then continue over the second. I don't care what you do as long as it's not just a random hodgepodge of putting things together. So I'm going to have plus or minus 1, 5, 1/2, 5 halves, 1/3, 5/3, 1/6, 5/6. Yeah? And again, it says possible. Just stop. Okay? Don't do more. Don't try to find what works. Okay? Questions? Don't be a repeat. Yeah. Yes, that's so. You could write the plus or minus with every single number. I'm just, okay, tell me plus or minus in front. I know you know what that means, okay? All right, let's try writing. Let's write a polynomial function. Of least degree with real coefficients in factored form given zeros of -5, 3, and 2i. It says factored form. So do you think I want you to take the time to multiply it all out? Please don't. And then it also says real coefficients. So do you think you should have any imaginaries left in your answer? No. So it's factored, but you're going to multiply just enough to get rid of the imaginaries. Okay? So let's see what you remember about imaginary solutions. Anybody remember anything about imaginary? Yes, your imaginary solutions come in pairs, right? So if 2i is one of them, we know -2i is one of them. Okay? I think you guys know how to write the factors, but I want to make sure you understand like where the factors come from. So if I'm telling you these are your zeros, that means x equals -5, x equals 3, x equals 2i, and x equals -2i, right? Okay? If I wanted a 0 on one side of this, it'd be x plus 5 equals 0, right? X minus 3 equals 0, x minus 2i equals 0, and x plus 2i equals 0. Okay, that's why those are our factors. It's simple with these. Some of the imaginary ones, it'll help you with your signs a little to think about that. So I want a polynomial function, so I'm going to say f of x equals, you can say y equals, pick whatever letter g of x you want. Make sure it's an equation though, okay? And then it would be x plus 5 times x minus 3 times x minus 2i times x plus 2i. Okay, yes, that's factored, but do I have real coefficients right now? No. So which ones do you think I need to multiply together? Yeah, so leave those first ones alone. Leave it alone, the x plus 5, x minus 3. So when I multiply this, I get x squared, and then plus 2xi minus 2xi. So what happens to those? They're gone. And then minus 4i squared. Yeah. Good. I squared is -1. You guys remember. So I'm going to just change that to +4. Okay. And that's your polynomial in factored form with real coefficients. Does that make sense where I want you to go with that? That's where I want you to stop. Okay. All right, let's do another one of those. So same directions as the last one. We don't need to rewrite all of that. Your zeros this time are 2, -3, and 4 plus I. So write your polynomial in factored form, real coefficients with these zeros. Do you know another zero?
Yes.
Yes. What is it? 4 minus I. Okay, just the sign in front of the I will change. That's what makes them conjugates. So remember, if you need to, think about this is what it means to have these zeros. So your factors are going to be x minus 2, x plus 3, and then what are you going to get for your next ones? Say it again. No. So think about that's why I write them this way to make you think about it. If I wanted a 0 over here, what would I do? Yeah, so it's going to be -4 minus I. It's just a good way to check, like, oh, okay, do I have my signs? And then what's this one going to be? Okay, I'm going to give you a second to multiply. Which 2 do you need to multiply? The last 2, okay? You want to distribute, go for it. You want to multiply in a box, go for it. I don't care how to multiply, I just want you to multiply for it. like most of you are there. You write it up here just so you can check. So your final answer should be f of x equals x minus 2, x plus 3, x squared minus 8x plus 17. Okay? How'd we do? Any questions before we move on to something else? Okay. All right. We're going to use the given 0 to find all zeros. Okay, so your f of x is 2x to the 5th. So how many zeros are we going to find? Yeah. Plus x to the 4th minus 7x cubed plus 21x squared minus 225x plus 10h. Ooh, okay. And it gets even better, guys. The 0 I give you is 3i. Okay? We have 10 minutes, guys. We can totally do this. All right, so there are actually 2 ways you can go about doing this. Okay? I want you to think about it. You know one 0, so you know another 0. Okay? You can either use those one at a time, the synthetic division, which is weird with a whole bunch of i's, but it works out nicely in the end. Or there's another way where you could use both zeros at once. I'm going to let you think about it. This is our last example, too, guys. The last one. I don't know which one. Just because we're short on time, I'm not going to show you the synthetic division way. I'm going to show you the other way. You guys keep working if you're good, though. So guys, when you get through your division, what should your remainder be? 0, okay? These are factors of it. So if you don't get 0, you know something went wrong. Now I'm at this 2x cubed plus x squared minus 25x plus 12. How are we doing? Are you guys there, close to that? There? How do you solve that? P over Q, yes, because does it factor? No, so you have to start with a P over Q list from that. I will help you out. Try 3. Okay. So you can make your whole, rewrite it down. Make your whole P over Q list, which is lengthy. Again, I'd try 3.
Is it plus or minus 1, 2?
Yeah, down here, it's fine. It gives you plus or minus all of the fractions at the end. You guys, you have like 3 minutes, so that's why I'm going kind of quickly through these. All right, guys, so are you getting 1/2, -4, 3, and then plus or minus 3i is your solution? Are you with me? Did I lose you guys along the way, or are we okay? I know it's long and tedious, but does it make sense? Okay. All right, let's look at your homework. We're going to skip a few on your homework. So, homework 2-2, skip numbers 4 and 5. Actually, 6 and 7 too. We're skipping 2 more. Skip 10 and skip 15. We're skipping quite a few there. That shortens your homework up a bit, but some of these, take a little while. All right? We made it, guys.